Okay, this is just a little video tutorial on general solutions for the Extension 1 Mathematics course. Now on your formula sheet you have the following. If sine theta equals alpha, then theta, the general solution for theta, in other words all the possible values of theta, will be pi times n plus -1 to the power of n, and then the sine to the -1 of alpha. Now this sine to the -1 of alpha bit means the following. Just, if you look at, if I just let, say, theta equal sine to the -1, so we're just investigating this sine to the -1 alpha. If theta equals sine to the -1 of alpha, then sine theta equals alpha. Look, just watch. If you were working out theta, wouldn't it be sine to the -1? Let's say I've got sine theta is a half. Don't you go theta is sine to the -1 of a half? So if sine theta equals alpha, then theta is sine to the -1 of alpha. In other words, anyway, you'll see it in an example. I think it's just best to do the example. So this is what this sine to the -1 of alpha is. It's actually just what the theta is. It's just working out this acute angle theta. That's all it's doing. Now, we'll have an example. We'll do an example of sine, an example of cos, and an example of tan. This example will be, so what will happen, you'll be doing a trig equation and you'll get down to this last step. And normally, if you were to solve this, wouldn't you say, from 0 to 360, for example, wouldn't you say, right, sine theta is positive in quadrants 1 and 2. You work out your acute angle, and then you'll work out your quadrant 1 answer and your quadrant 2 answer, because sine is positive in quadrants 1 and 2. But when you do general solution, you just want the acute angle. Start with the acute angle, that's your alpha. See, look at the formula sheet. Sine theta equals alpha. That's alpha. Can you compare that and compare that? That's alpha. Therefore, they're saying theta, see this sine to the -1 alpha? They're just working out theta. That sine to the -1 alpha is just the theta. Sine of what is √3 on 2? Yeah, so theta, the way, if you wanted, you could do it on your calculator, but you don't because it's an exact value. But if it was any other number that's not an exact value, how would you find that angle? That theta is sine to the -1 of that. That's what this is. See this bit on the end? It's just theta. The acute angle theta, that's all that bit on the end is. So isn't that, but you know sine 60, it's 60, okay? You can always use the calculator if you want for this, but you should know your general. But do you get that sine to the -1 of alpha, if you do it, it actually just gives you that theta? That's what that is. So the formula would be much nicer if they actually just wrote 180n plus -1n theta, the acute angle but, right? So theta, that sine to the -1 alpha is 60. So therefore the general solution is theta equals, let's just, isn't it 180n plus -1 to the power of n times your sine to the -1 of alpha is just the 60. That's the general solution for that one, but this is the most basic type. We've got to do other types. Then we're going to look at the negative type. Let's say I gave you sine theta is -1/2. Now, the definition is that this angle has to be an acute angle. Sometimes this angle's positive, sometimes it's negative. Now, this is not a quadrant 1 answer. Sine of something in quadrant 1 will never give you a half. It has to be quadrant 4, because all stations to central, all of them are positive in quadrant 1. So yes, sine of 60 will equal that, because sine of 60 is not -1/2. Sine of -60 will be -1/2, okay? So therefore your acute angle this time is not positive 60, but it's -60. Now, 30, yeah, thank you. It's 30, sorry everyone. So it's 30, but it'll be -30. Are you okay with that? If you want, why don't you go, theta is sine to the -1 of -1/2. You should get -30, but look, anyway, sine to the -1 of -1/2, just try it and you'll get -30. All right, if it works, then you can use your calc. But look, you should know that, yes, acute angle's 30, but I need the smallest acute angle. You wouldn't go to, we know quadrant 1 and 2 are positive, you wouldn't go to quadrant 3. Quadrant 1 and quadrant 4 are the ones we use most of the time, except for cos when it's negative. We have to do something else, all right? So for sine, if sine is positive, it's quadrant 1. If cos is positive, it's quadrant 1. If tan is positive, it's quadrant 1. But if sine is negative, you go to quadrant 4 angle, because that's the smallest acute angle where sine is negative. So this would be negative 30 here. So theta is negative 30, so therefore the general solution of that one is theta equals 180n plus negative 1 to the power of n times negative 30. Now, I'm going to put that negative in front here, so it'll be 180n minus negative 1 to the power of n times 30. We don't keep it as plus negative 30, because it's plus times that times negative 30. Now, this negative 1 to the power of n, if n is odd, that negative 1 stays. If n is even, that negative 1 goes. Negative 1 squared is positive 1. See, that's why sometimes so if I decided to work out, put in any 0, 1, 2, 3, you'll be able to see, do you get what I'm saying? Do you want me to do it or no? You sure? All right. But what would happen if that was 0? What would happen? Let's just have a little look. What if n is 0? What would you get? Would you get 0 there? You'd get negative. What's negative 1 to the power of 0? What's anything to the power of 0? Yeah, so you'd get negative 30 for your first angle. Theta. So if n was 0, you'd get theta is negative 30. Yeah, that's good. Where's your next negative sign answer going to be? It's going to be quadrant 3, which is negative 150. Let's see. Or it could be positive 210. I'll just see what we get. N is 1. What have we got? If n is 1, you get 180 minus negative 1 to the 1 is negative 1, so it's plus 30. You get the 210 angle, so it came this way. All right? N is 2. What do we get? Theta is 360 minus, now negative 1 squared is positive 1. So the minus here stays, minus 30. 330. Yep, all the way round. See how they're working? N is 3 would give you another one that would work. 180 times, that's 540, minus negative 1 cubed is still a minus, so you go plus 30. 570. Now 570 I think is just the 210 answer, and you add 360 to it. It's the next circle, etc. So that's why that's the general solution where n equals 0, 1, etc. All right? Now, that's general solution, sine positive, sine negative. So if sine is negative, you have to go to quadrant 4. All right? Because where is sine negative? Quadrants 3 or 4. Now, another example. Cos theta is 1 on root 2. We'll do some exacts. General solution. What's the acute angle? Theta is cos acute. You can write here acute angle. Do you know what I mean? So I should write acute angle for all these. Acute angle. So I'm putting, when I do that, I'm going acute angle is 60. Acute angle is negative 30. All right? Acute angle, cos to the minus 1 of 1 on root 2. You tell me, cos of what? Yeah, it's 45. Now that's positive. So the solution for cos is, general solution, theta equals 360n plus or minus, this one's a nice easy one, cos to the minus 1 of 40, cos to the minus 1 of alpha, cos to the minus 1 of 1 on root 2. But you know now that that's your angle. So it's just 360n plus or minus, what's your angle? 45. So if you recognise that cos to the minus 1 of 1 on root 2, it's actually just the solution to that. It's the theta. See, theta is cos to the minus 1 of 1 on root 2. That's what that is. That's your alpha in your formula sheet. So, but if it's negative, you've got a bit of a, this is the situation where it's quite different. Cos of theta is negative, let's go root 3 on 2. Now, cos of what is, don't worry about the negative. Oh, actually we will. All stations to central. Where is cos negative? 2 and 3, not in 4. So there's no negative 30 or whatever it might be. Is it cos of 30 is root 3 on 2?
Yeah.
Yes, it is.
Yeah.
All right. So it's not 30 because you're not negative in quadrant 4. So where's the next place where it will be negative? The smallest angle where it could be negative is quadrant 2. So you have to use the quadrant 2 result. Now we know that the acute angle is 30. But the first time where cos is negative in the circle will be cos of 150. See how I've put the 30 in here in quadrant 2? Because that's the first place it will be. It's not negative down here and or there. So you have to say the acute angle, but it's not acute this time. So just go angle theta is going to be 150 degrees. So whenever cos, this is the really tricky one, whenever you have cos of theta equals a negative, you must use quadrant 2 as your smallest angle. Well, your supposed acute angle, but it's not acute. So now the formula becomes theta equals 360n plus or minus 150. Okay? That's the trickiest one. Tan is the same as sine, quadrants 1 and 4. So tan theta, let's say, is root 3, general solution. We're just doing the basic types first. So, but the main thing here, this is always tricky, and a lot of people, but if you do your all stations to central, you'll see that cos can't be in quadrant 4 here. Next best, smallest angle is quadrant 2, where cos is negative. Tan theta is root 3. Theta is tan to the minus 1 of root 3. This is your acute angle. Isn't it 60? So therefore, the formula says theta is 180n plus tan to the minus 1 of your angle, which is? Sorry, tan to the minus 1 of whatever root 3. It's just going to be 180n plus or minus, no, just plus, sorry, your angle, 60. I really think that their notation makes it harder. That tan to the minus 1 of 3 is your 60. Now, but for negative tan angles, tan of theta, let's say, is negative 1. Okay, all stations to central. We want the negative. Can tan be negative in quadrant 4? So I need the quadrant 4 angle. Tan of what is 1, by the way? 45. But acute angle, it has to be negative 45. It's down here. So therefore the formula is theta is 180n plus your angle, tan to the minus 1 of, yeah, I don't like writing it like that. I would just go 180n and your angle plus negative 45, you get it, which is 180n minus 45. Now they're the easy types. We're going to start doing the harder ones. If you look at these two equations, they're different. One is sin x plus cos x is 0. That's the easy one to solve. This one, sin x plus cos x equals a constant. You have to use T formula or auxiliary angle method to solve this type. So when you've got sin x plus cos x is 0, it's not so hard because you can just take the cos x over. 3 sin x equals negative cos x. How do you solve an equation when you've got sine equals cos? You divide it by cos because sine and cos make tan. So now what we do, we divide both sides by cos. And I'm going to move that 3 over if I can I? In a minute. So I've got 3 tan x equals what? Yeah. What am I going to do with that? So tan x is negative 1/3. Now general solution. What's that? So you're going to work out, you know you're in the negatives. You've got to go quadrant 4. Sine is negative, tan is negative, quadrant 4, except for cos, because cos isn't negative in quadrant 4. The next place you go is quadrant 2. Yeah. So, acute angle, x. Now, this is not an exact tan to the minus 1. Look, I just put in your third. You can put the negative. I think the negative will work.
It's negative 18.
Degrees. All right, give me degrees in minutes.
Negative 18 degrees, 26 minutes, and 5.8.
So 26 minutes is closest. So that's to the nearest degree minute, okay? You can put, if you don't put the negative in, you'll get a positive answer, and then you put the negative in front. Or, yeah. Okay, so then, therefore, the general solution x is, for tan, it's 180n plus your angle, negative 18 degrees, 26 minutes, which is just 180n minus 18 degrees, 26 minutes. All right, that's the general solution of that one. This one, auxiliary angle method. You can't put the cos on the other side and divide by cos. Do you remember how to do? So whenever you see something of the format, a sine x plus b cos x equals c, where a, b and c are constants, you have to either use T formula or auxiliary angle method.
The T formula one that's like
2t.
On 1 minus 2. Auxiliary angle one? I don't know. What's the auxiliary? That's like r cos theta. Oh, no, I don't know what that is. I don't know. I looked at it last night and went, no.
We'll practice it. Remember the double angle result. So cos 2 theta, from the formula sheet, you can see that it's cos squared theta minus sine squared theta. Now, I know, yes, you can replace these with, that's 1 minus sine squared, for example, and sine squared is 1 minus cos squared, but this is how I think of it. This is the double angle result for cos. So is it 2 cos squared theta minus 1, or is it 1 minus 2 cos squared theta? Because it's the double angle result for cos, I think, well, the cos one is the positive one. It comes first. It's the 2 cos squared theta minus 1. Do you get what I'm saying? Whereas the double angle result for cos in terms of sine only is the 1 minus 2 sine squared theta. How do I remember it? I say this is the double angle one for cos. So the cos one here is positive for it. 2 cos squared minus 1. And this is the double angle result for cos, but this is the sine version. So I've got the minus 1. Yeah, that's how I remember it. Then, what else we were talking about? We were saying something else. Yes. Right, sine squared theta plus cos squared theta equals 1. That's a two-unit result.
Yeah.
The way I remember the others is it's 1 plus tan squared equals sec squared. 1 plus tan squared theta equals sec squared theta. Now, when I write out these three, you've got to use all 6 ratios. We've got sine cos in the original, tan and sec. What's left is cosec and cot. 1 plus little c equals big C. 1 plus, which one's shorter, cot or cosec? Cot. 1 plus little c equals big C. And that's how I remember them. It's and 1 plus little c equals big C. Doesn't it make sense? 2 small things make the big thing. Okay, that's how I remember them. It's 1 plus tan squared equals sec squared, but you can, the way to do it is to divide them both all by sine squared. If you divide by sine squared, you get 1. If you divide by sine squared, you get cot. If you divide by sine, you get cosec. Or you divide them all by cos. If you divide this by cos squared, you get tan squared. If you divide this by cos squared, you get 1. If you divide this by cos squared, you get sec squared. But I prefer to remember it's and 1 plus little c equals big C. Okay. What we're discussing is that if you put cos to the minus 1 of negative a half, say here, the calculator will spit out 120 for you. If you do cos to the minus 1 of 1 here, your calculator will work out the 0 for you. If you put, for example, here sine to the minus 1 of negative 1, it will do the negative 90 for you. So you actually don't have to work out the smallest angle. If you're putting the negative and the positive in, it will work it out for you. Okay? Now we're going to look at some harder examples of general solution, and we'll have to look at auxiliary angle method. All right, show me that one from, anyone got the Cambridge? General solution. What if I give you tan of 2 theta plus 30, this is a horrible one, equals 1. General solution. No, it's not as bad as what you think. Remember, treat this all as one thing. Okay? So, tan, that's your new acute angle. So, acute angle 2 theta plus 30 will be tan to the minus 1 of 1, which is 45. So this is what I've got. That instead of just say x here, it's just that, but don't worry, just treat it as a normal theta, but acute of that is that. So what's the answer? Isn't it 2 theta plus 30? Is this how the formula goes? Equals 180n for tan plus the 45. Now, all you do, what do you think you do? You subtract 30.
And divide it by 2.
Yeah, that's it. So we go 2 theta is 180n plus 45 minus 30, but we need to do a cos one because that's trickier, which is 2 theta is 180n plus 15. Now we divide everything by 2 and you get 90n plus 7.5. That's one type. We can do, all right, let's do a cos of 3 theta minus, I don't know how bad this is going to be, minus 45 equals root 3 on 2.
Miss, would they ever give us a question where it...
Negative root 3 on 2. Negative and worse.
Would it ever be like, they could be like 3 theta minus like 7.5?
No. Oh, look, it doesn't matter what it is because it doesn't matter what I put here because I'm just going to add it to the other side later. At the moment, just treat this as one thing. Don't let it frighten you. So therefore that the acute or the smallest angle, 3 theta minus 45, don't you do cos to the minus 1 of this on your calculator?
Would I include the
Oh, and the negative, yes, because it's going to give us quadrant 2. Well, what is it? What cos of what?
It's 130, 150.
Yeah, because it's 30. Good. So this is what we've got. 3 theta minus 45. That's your little smallest angle. Do you know what I mean? So the rule is, so this one's a bit trickier, is 360n plus or minus the 150. So you just break it up. You've got 360n plus 150 and 360n minus 150. So we break it up into 2 sections. Because when you start minusing 45, you've got to work them both out. You're going to get different answers. So our first one is 3 theta minus 45. We say take the high road, take the low road. So you do the plus 1 first, 360n plus 150. And then we're going to do 3 theta minus 45 equals 360n minus 150. So just start rearranging. 3 theta is 360n, is that going to be plus?
Yes.
So you get plus 195. And divide it by 3. 120n plus, I think it's 65. 65? Got it? This one, it's really important to do the minus 150 and separate it because you're going to get different answers. 3 theta is 360n minus 150 plus 45, which is minus 105. See how it's different? It's not going to be plus or minus 65 because you're going plus 150 plus 45 minus 150 plus 45. And we get theta is 120 n, I forgot the n, minus 35, isn't it? Yeah.
So we've got 2 solutions.
Yes, 2 different ones. The reason is because you got the plus or minus 150. So you've always get 2 solutions for cos. But when you've got something out the front here, you've got to break them up.
So we don't have to test.
No, they'll all work.
They both work.
They'll both work.
Okay.
Yeah. Always for cos, you always have 2 solutions. Look. But the problem is you can just write it as plus or minus when it's the simplest type. But when you've got to start adding angles from the other side and break it up, the plus will come out. If I just went plus 1 plus 45 here, I'd get the right answer for this one, but the wrong answer for that one. Because you've got to go minus 150 plus 45.
Yeah.
So you need to break up the cos one if you've got something complicated at the front. Now, where's that one from the past paper, which you should now find very easy?
I'll pull it up real quick.
I think it was tan 3 theta minus 1 is something or something. Tan 3 theta minus 45 is 1. I can't remember. What are you going to do? That smallest angle, it will be acute this time. Acute 3 theta minus 15 is tan to the minus 1 of 1, which is?
45.
Yeah. So then you set up your thing. Instead of putting theta equals, you've got that's your whole theta. 3 theta minus 15 equals 180n plus the angle. Is that bad?
It looks so bad.
So 3 theta is 180n plus 45 plus 15, which is 180n plus 60. And now we just divide by 60n plus 20.
Wow.
And if that was negative, you would have had a negative here.
Yeah.
Sine one will be maybe a bit harder. We can do a tricky one with sine.
Miss, there was one question that you did. It was cos theta.
So if you see something like that, SOHCAHTOA, sine, cos, tan always means you can draw a right angle triangle.
Yeah.
Theta, 5 on 13, the other side's 12. 5, 12, 13, Pythagorean triad. So now you can work out sine theta. Oh, did it say which quadrant? Did it give other
said,
things?
180, like the.
All right, no, give me exactly the question. Cos theta is 5 on 13.
And 0 is less than equal to theta, which is less than equal to 180.
So we're in quadrants 1 and 2. So this has to be quadrant 1 for cos to be positive.
Determine the value.
Yeah, so sine theta will also be positive for quadrant 2. See, this is telling you that you're in quadrants 1 and 2.
Yeah.
But because cos is positive, you have to be in quadrant 1 now. Quadrants 1 or 4, cos is positive. So it's got to be quadrant 1 because it's the only overlap between 1 and 2, and 1 and 4, the overlap is 1. So you have to be in quadrant 1. We know that sine is positive in quadrant 1. Sine theta is 12 on 13. And you have to come up with the sine 2 theta.
Yeah.
Is 2 sine theta cos theta. You don't go and double anything. You don't find the sides of the angle, double it and do sine of it. You don't do it like that. You do it like this. So it's 2 times whatever sine theta is times whatever cos theta is. Now,
120 on 169.
yeah. Now, the question, if I had a negative here,
Then you know you're in a different quadrant.
you'd be in quadrant 2 for this one, but sine would still be positive.
Yeah.
If I did 0 to 360 negative, it'd have to be quadrant
It'd still be quadrant 2.
3. No, let's say I do the same question. Cos theta is negative 5 on 13, 0 to 360.
And would it still be determined?
And I want to find out sine 2 theta.
But wouldn't it be positive sine 2 theta?
Well, which quadrant are you in?
Oh.
Quadrant 2 or 3?
And if sine's positive. If sine's
Oh.
positive, it's quadrant 2.
Yeah, and it might tell you, and sine, let's say, and sine is negative. Let's say they told you sine is negative.
So it'd be quadrant
It'd be in quadrant 3. Yeah. Oh, yeah, let's say they told you, that it was from 180 to 360 or something. Do you know what I mean?
Yeah.
So you'd have to be in quadrant 3. This would have to be negative
Yeah.
or whatever, something like that. So you'd get negative 12 on 13. So sine 2 theta would be 2 sine theta cos theta, which would be 2 times the negative, which gives you a positive answer.
Yeah.
All right, so you've just got to see what quadrant you're in. It will give you the... Now, so with this one, we've got this equation. Root 5 sine x plus 2 cos x equals negative 2. This has sine, cos, and a constant. Forget taking the cos to the other side and dividing by cos. You can't. If that was equal to 0, you could. So you have to use what's called the auxiliary angle method or the T formula. Now, it does say here, transform the left-hand side of that equation into this form, c sine x plus alpha. You haven't seen it? R sine, yeah. Yeah, same thing. So what we're going to do, we're going to transform this, I'll put an R, equals R, and it tells you R sine x plus alpha. Now, this is sum and differences of angles. You're supposed to be able to expand this. R sine cos, isn't it? Sine x cos alpha. With sine, keep the sign the same when you expand, plus R. See, I can put the R bracket and then write the R out again. I don't want to write the R, I don't want to write it out and then expand with R. So it'll be R sine that, and then what comes next? Cos x sine alpha. Now, I have to compare that with this. Now, watch what I'm going to do. I'm just going to swap these two around. R cos alpha sine x plus R sine alpha cos x, right? The reason I'm doing that, I'm underlining sine x and sine x there. The root 5 equals R cos alpha. So I've got R cos alpha equals root 5. So therefore cos alpha is root 5 on R. So this is how you're supposed to set it up. They will tell you to put this in that form. What you do here is you expand this using your double angle results. You swap those two around always. And looking here, cos x is cos x. So what does R sine alpha equal? 2. Now you put it in the format sine alpha is 2 on R, because whenever something's in that format, it's telling you to draw the right angle triangle. Now we've got the same angle alpha, so I should be able to draw the one triangle. Where do I put the root 5 and where do I put the R?
Root 5 is on the bottom, and then alpha is the hypotenuse.
The R is the hypotenuse, and for this one? 2 is there. This is why you learn the formula. How do you work out the hypotenuse? Isn't it square and then square rooted? So it's the square root of 2 squared plus root 5. That's the formula you were given. R is the square root of a squared plus b squared. So this is where it comes from. Which is 4 plus 5 root 9, which is 3. And you've got opposite and adjacent, and you get the other formula. Tan alpha is negative 10 to the minus 1 of b on a is alpha or something you get. Tan of alpha is 2 on root 5. So with this way, you don't have to learn how to do the formula. You don't have to learn the formula. All right, yes, it's 3 lines, but this is how, if you're asked to show it, you're supposed to be able to do this.
Yeah.
You look at all the HSC solutions, they're done like that. Okay? The textbook does the formula, but I don't think you're meant to. All right?
I understand the formula.
Yeah. Well, do you get this? Do you get why that equates with that? Yep. And then just this, draw a right angle triangle, and you can work out the angle and the hypotenuse from that, and whatever you get for that, you will get an angle.
So then it becomes 3 cos.
So therefore, we can say that root 5 sine x plus 2 cos x equals, now the R is 3 sine x plus, I could write 10 to the minus 1 of 2 on root 5, but can you work it out for me? What?
Which one?
This angle.
Yeah.
So therefore, theta, alpha is?
41 degrees, 48.
And how many seconds?
37.
That's over halfway.
It's 49.
49. Plus 41 degrees, 49 minutes. Okay, so we've got that. So transform it into that, where alpha, it lies between 0 and 360. Normally it's got to lie between 0 and 90 actually. Don't know why they've got 0 and 360. That, on the question thing, that's meant to be 90. All right, it's just a mistake. Then it says, find correct to the nearest minute where necessary the solutions for the equation. So in this format, you know how I said to you, in this format, you can't solve it unless you use auxiliary method or T formula. Now you can replace this with that, and it becomes a normal equation. So instead of that, we use this.
Oh, and then it's just the general solution.
Well, if you want a general solution, you can. Or you can do normal solution if you want. So if you want, we can do general. Let's practice the general now that you're experts. So we've got sine of, pretend that's just one angle, don't let it freak you out. You put the negative, shift sign, negative 2/3. So we're going to go the acute angle, x plus 41 degrees, 49 minutes, will be sine to the minus 1 of the negative 2/3, which is negative
41 degrees, 49 minutes.
Really, it's the same. Okay.
Yeah, it's the same.
All right.
Oh,
It's going to cancel.
Oh,
No, or it's going to double.
no.
All right, so therefore the general solution of x plus 41 degrees, 49 minutes, because we're doing sine, the solution is 180n plus negative 1 to the power of n, and then the angle, which is negative 41 degrees, 49 minutes. So girls, if you had to solve this the other way, you know what you'd do, wouldn't you? You just do, they wanted you to actually solve it for 0 to 360. If you were to do it, the acute angle is 41/49, but it's quadrants 2 and 3. No, it's quadrants 3 and 4. You would have gone, this would have been your answer. So if you were asked, if you were asked for 0 to 360, remember you've got to add, you've got to change your domain. Your domain has to go beyond, where do we want to do that? Wait, I'm just doing general now. But if you want to do it that way, you've got to add, you have to go from 41/49 up to 401/49. Because you've got x plus 41. You know, when your domain, you've got to change your domain. Look, just make sure in the end that your answer's between 0 and 360. That's your other way. But because that's for 0 to 360, x lies between 0 and 360, you're doing x plus 41. So you've got from 41 to 401. So that one's in, that one's in. You know, you're okay, it's just those two. Do you get, have you done that? Yeah. So you would just go 180 plus 41. What's that? 221/49. But you've got to write x plus that is that, and then you subtract.
Yeah.
I think I've got some of those on some of those sheets that you see, all right? And then you go 360 minus, but then when you're done, you've got a minus 40. Because that's what x plus 41/49 is.
Yeah.
Oh, wait, I'm really messy.
Okay.
I can do that in a minute. Let me just finish the general solution. So we've got that with the general solution, which is 180n. What happens? Plus, minus?
It becomes a minus.
Minus negative 1 to the n, 41 degrees, 49 minutes. Now, you just bring that over. It doesn't actually cancel because that's multiplied by negative 1 to the n. So it's x equals 180n minus negative 1 to the n, 41 degrees, 49 minutes, minus 41 degrees, 49 minutes on its own. I'm not going to start playing. Well, you could factorize out the 41 degrees, 49 minutes, negative 1 to the n plus 1, like something, but all right. But yeah, that's the general solution. Now, if you were to do it the other way, just the two solutions, like we were about to do. Let's say you just want 0 to 360. Well, I'm not doing just x, I'm doing x plus 41, 49. So I add 41/49 to each of these parts, and I'm going from 41/49 all the way to 401/49. So you draw your triangle. We know that the acute angle of that happened to be 41/49. So quadrants, what quadrants are you in? So this is just solving for 0 to 360. What quadrants is this negative telling you?
3 and 4.
Quadrants 3 and 4. So you put your 41/49 in 3 and 4. So you're not solving just for x, you're solving for x plus. So therefore x plus 41 degrees, 49 minutes. Quadrant 3 is 180 plus that, which is 201/49. Quadrant 4 is 360 minus that. Yeah, 318/11. But now what do you do with each of these?
You have to take away 41.
Now we take away, and you get minus, what is it, 201? 180 plus 221.
180 plus, yeah.
221. So if I take that away, I get 180, don't I?
Yeah.
And this is, I can't do that in my head.
180.
11 minus 4149.
You get 276. 22.
All right, and that's how you do auxiliary angle method. Now I've got